In number 4, in my function, first thing I like to do is I like to talk about my vertical asymptotes. So in number 4, my vertical asymptote will always be some kind of x equals, and it's whatever makes the bottom 0. So in this case, -1.
Yeah.
And then, after I do that, I'm going to look for some kind of some horizontal asymptote. Is there one?
Well, it has to be something to infinity because it's...
Yeah, and that doesn't make any sense for horizontal. So there's no horizontal, but ooh. I have something new to show you. Oh, God.
Okay, everybody.
Watch this.
Yeah, already that is.
Tell me what I'm doing right now.
Drawing the
Good one, Ben.
It's called long division, people. X goes into x squared, x times x is x squared. X times 1 is positive 1x. I subtract off. And my remainder is -1 x. And then I have to turn the x into -1, so I would multiply by -1. This thing that you see here on the top, once you get to the constant, if there's a constant involved, so any x term and any constant together is what they call a slant asymptote. Oh no, I would never do that. That's why I'm teaching it to you, so that you don't have to remember it or don't have to worry about it on the test. So now I go with x minus 1 as my slant asymptote. Looks something like that. And if I were to graph this one, it would look like this. And you can do this later. And what I want to tell you about slant asymptotes, in case you didn't know, is if the power, that's bad color. If power on top exactly 1 more than the bottom. So if you look at the original problem, what you will see is that on the top we have an x squared, and on the bottom we have an x. X squared has a power of 2, x has a power of 1. There's exactly 1 more on the top than the bottom, 2 versus 1. So if the top was an x5 and the bottom was an x4 for the biggest powers, top and bottom, same kind of deal. Okay, so when it's exactly 1 difference, there's going to be a slant asymptote, not a horizontal. Slant, not a horizontal. It's in the video twice. Slant asymptote, not horizontal. Thanks, John. In this next problem, you'll see this absolute value thing on the bottom. So just as a reminder, you can get to the absolute value by doing math, num, ABS. That stands for absolute value if you wanted to graph it. Let's talk about that vertical asymptote. Notice how I've been doing all of these vertical asymptotes in red. So let's talk about the vertical asymptote. The vertical asymptote is x equals 1, because it's whatever makes the bottom 0. There's the vertical asymptote. Now the crazy thing is because we have an absolute value on the bottom, and you look at the horizontal asymptote, what I'm looking at is this 2x here and the x here. And 2x divided by x is
1, no 2.
2. So my horizontal asymptote, you would think, is y equals 2. However, the x in the denominator, the bottom, is inside of an absolute value, which means you could have the positive or the negative version. So don't forget to put plus or minus. So we actually have 2 horizontal asymptotes. One at positive 2 and one at negative 2. I would like you to grab your calculator and graph this and see if you get the same thing I get. Go. Okay, so the picture you see on the screen is what I get when I type it in on my calculator. And if I were drawing that over here, my graph would look like the following in the orange. Notice how the left part of the graph is obeying the vertical asymptote and the negative 2 horizontal asymptote. But the right part of the graph is obeying the vertical asymptote and the top horizontal. So each piece of the graph is obeying some of the asymptotes. And that's why there's more than 2, is because the right side pays attention to one of the horizontals and the left the other. I want to talk about number 7 first, and I'll come back to number 6. In number 7, they're talking about a limit. So you see this phrase in number 7, they're talking about these deer, and they say there's 500 to start with, and there's a population given by some kind of function, n of t. So n is the number of deer, t is the time in months. And they say carrying capacity. That phrase basically means the limit.
Yeah.
What's the limit?
Y value.
A y value. And all you got to do is look at the war. So in the war, when I talk about this, I see that on the top, if I have to talk about 500 or 350t, which one's more important?
T.
The t thing. And on the bottom, if I'm talking about 1 or 0.2t, which one's more important?
0.2.
0.2t. So all you do is you take those two numbers and you divide them. 350, and it's a t and a t, so they're the same, divided by 0.2, and you get 1,750. And that's it. Number 6, slight change of what actually happens. You probably should know that in this problem, the numerator is really the same as 2 times parentheses x minus 4. And the denominator is the same thing as x minus 5, x minus 4. What do you notice about the numerator and the denominator?
They both have x minus 4.
Excellent. They both have x minus 4. So as I notice that, what I would normally say is that this graph would have an asymptote of x equal to 4, a vertical asymptote, right?
Yeah.
That doesn't happen. When these two things match up, that means that you have a hole
Oh my.
at x equal to 4. And the only vertical asymptote that I have occurs at x equals positive 5. So at 5, I have a vertical asymptote. Do I have a horizontal asymptote?
Oh.
Maybe at 0. Right?
That's correct. Good job, Tristan.
Yeah.
Y equals 0. Because it's the small over the big, and there's a 2x on the top and x squared on the bottom, small over big is 0 for the horizontal asymptote. So I know those two things. If I go to graph this, here's the deal. I see this on my calculator. And when I graph the other thing, I see this. However, if you do this on your test, it's going to be wrong. Because there's a hole at
4.
x equal to 4. Don't say 4, say x equals 4, just like I wrote it on the screen. So what you're going to do is at 4,
Draw a circle. Circle.
you're going to put a hole. Son of a gun.
We draw a circle too.
If you want to, kid.
So here's the hole. If you want to know what that actual value would have been, had you drawn that hole there, and you want to see what the y value is down here, pretend like these two things canceled out, the x minus 4's, right, because they reduce. Take the 4 for the x value, plug it into what's left over. 4 minus 5 is
Take 1.
negative 1, and then on the top I had a 2, so 2 divided by negative 1? Negative 2. So that's where the y hole is occurring.